Hi, everybody. So apologies if I feel a little rushed. My demo just blew up right beforehand, so hopefully it'll go well once we start the talk. So cross your fingers. I know I am. So just in case you make sure you're in the right place, this is talking about the CDK. So that's the Container Development Kit, and kind of trying to show you how the integration with Eclipse works, as well as kind of try to explain what the CDK is and kind of what it does, as well as a little bit about kind of the tool chain that it provides so that you can kind of get a better understanding of what we're trying to accomplish with it. It's pretty early days, I think, for the Container Development Kit. Like, we really have a lot of ideas about what else we want to do with it, and we're really seeking feedback on what you guys would want from it as well. So please definitely give us feedback. So to get started, I'm Langdon White. I originally joined Red Hat as a what we now call an advocate rather than an evangelist. I guess there was too much crossover with television evangelism. But for RHEL, so basically I kind of covered the whole gamut of kind of all the different programming languages, with basically the exception of Java. So it makes a lot of sense for me to show off Eclipse for you. But I did spend something like 10 years as a Java developer, so I do have some experience with it. Now I'm actually a platform architect, so what that means is I'm responsible for kind of a portion of Enterprise Linux, being the architect for that. So that means I kind of, do architecting stuff, but also mostly it's actually about coordinating with the rest of platform to make sure that we actually deliver a unified product. And then lately, I've actually been working on a project called Fedora Modularity, which is basically the goal is to kind of revamp how Fedora works, such that it's kind of based around things called modules, so that there's a little bit more application independence and lifecycle independence. And then this is my son Thomas. He plays a lot of soccer, and he does a lot of homework. He goes to Boston Latin School, so it's a very tough school. But the reason I bring him up is because he uses Instagram to talk to his friends. And when I say that, it sounds kind of obvious, except what they actually do is they post a picture on Instagram, and then they comment back and forth, completely unrelated to the picture, so that it's much harder for their parents or whatever to track their communications. So I apologize if you've heard any of my other talks, because I have very few jokes, so you've heard this one before. But he actually, before I gave this talk, I told him I was going to make this joke yet again, and he's like, that's so last week. We're actually all Snapchat now. And Snap, I don't know, it's just awful. I try to use it, I don't get it. I don't know, maybe I'm just old. So there you go, a little bit of insight into the 13-year-old teenage mind. All right, so this is a little bit of agenda, because you're supposed to have an agenda slide. So here it is. So what's the deal with containers? Where we're going to start. Then kind of what's the CDK? I'm going to try to show it to you, and maybe an example of kind of it working. And then I'm always supposed to, I have the reason this slide is here, so I remind myself to tell you to don't forget the surveys. That's how we decide what are good talks to bring to you, like what are you interested in, so that we know for next time to make sure we have good talks. And then there's some related talks, although actually now I realized it, one of the talks was actually yesterday, so I apologize. You can't go to that one. And also thanks to the people I stole pictures from. Borrowed, attribution, all that. So the first thing, so kind of talking about containers and what's the deal, right? So if any of you are as old as me or older, you'll probably remember in the late 90s, one of the big reasons for the Linux distro to kind of come around was being able to control the end, right? So being able to control your own system by essentially enforcing on application developers decomposition, so that the various libraries across the machine would be shared, right? So that, if there was an OpenSSL bug, you could patch it in one place, and it would pay patch for everything. The downside to that is that's very sysadmin control side, right? And that was a good thing then. However, what is started to happen in recent years is, I kind of refer to it as like the pendulum swing, right? In software, we tend to see how far we can really get with those pendulums, right? And we're very bad at staying in the middle. And so it started to favor developers quite a bit more. So my old joke as a consultant was kind of like, when I build an app, right, and I go talk to the CEO and say, hey, this is making $1 million a day, we should be putting it in production. I don't care what the sysadmins say, right, it's going to production, right? I mean, it's just kind of how it works, especially more recently. So that, so not only has kind of that pendulum swung, but then like how we build software, right? Open source has won, right? Everything has open source now. Open source is, in most organizations, pretty much okay. I still remember like having to like hide using open source software at all, right? And it was just kind of crazy. We have things like DevOps, we have Agile, we have all these different things that have changed how we approach software development. And one of the things that's interesting is kind of like I mentioned before is that decomposition has actually gotten so that it's kind of decomposition by service level. Now, we're not allowed to say SOA anymore, right, because that's a bad word. It kind of blew up in the early 2000s. So now we call it microservices. But basically, you're kind of talking about the same thing, right? You're saying we're going to decompose this application into its various parts so that they can scale linear or independently of each other. They also may have different life cycles, which I think is the next slide. Nope. Sorry. So they may have different life cycles, so you want them to have some independence from each other. And so that's why we kind of talk about decomposition as being an interesting thing. And this is particularly true if you read anybody about who's kind of advising you about how you should do containers, right? Single service containers. Then the last part that's kind of a big deal with the containers, like I was saying about that pendulum swing back to developers, this whole, hey, it ran on my machine thing doesn't work for, kind of production environments, right? So what a container lets you do is say, here is all the things I need, and I'm going to put it into this big blob, and then I'm going to be able to deploy that to production. And I know, one of the good things that's changed about software development, right, is that we actually go through a CI infrastructure a lot of the time, good testing, all those things. But what we know now, if we use something like a container, is we know that what we built, what we tested, is what's actually in production. So kind of going back to my OpenSSL example, it's a relatively rare thing, but, and maybe that's not the best example because they're pretty good about being backwards compatible and all that. But some of the more esoteric libraries, when they patch something, that may actually break the developer's code, right? Because the developer may have noticed the bug and written a workaround, but wasn't able to, kind of get the change made upstream for whatever reason. They were too busy. They weren't successful at talking to the people or convincing them or whatever. So now when you patched it, you've actually introduced a bug. So that's part of the fear that a lot of developers and organizations have right around their applications. So they actually will build basically their complete application stack, never do kind of a yum update on their application stack because they don't trust that the whole unit has been tested sufficiently. So part of that's paranoia, but when, like going back to the $1 million a day example, right, or some of the trading apps I worked in, $1 million a minute, that paranoia is kind of a good thing, right? So, but it results in a lot of work. So that's what I'm kind of talking about. Maybe the pendulum swung a little too far, right? So now you have developers with kind of complete control, which is a little dangerous too. And the last part that I kind of want to bring up is when you're talking about containers is the content in the container matters, right? And I use this graphic, which is actually supposed to be for something completely different inside like Red Hat marketing. But I like this graphic to kind of show like, there's a lot of curation we do, right? We take this content from upstream and we kind of ensure that it meets a certain level of quality guidelines. And then when we push it into something like a container, we know where it came from, right? We know what the source was. We know that it's of reasonably good quality, or we at least know what risks to take on. And when if you kind of follow the general, what seems to be the general internet advice around containers, you should be able to just pull anything, right? However, if you've ever worked as a sysadmin, you definitely want to be able to see, basically know the provenance of anything that's inside your container. So that's why I kind of throw this graphic up here. But so, kind of wrapping that part up, it's not all rainbows, right? It's cool, and it's useful, and it has a lot of advantages, and it really does start to really help with that decomposition of applications, which really makes a big difference to, like I said, kind of scale and being able to horizontally scale and stuff like that. And then on top of that, the problem with that, right, is that it often means kind of re-architecting, right? One of the nice things about the push with microservices is that the re-architecting isn't happening in some, kind of ivory tower with the architecture team coming up with every interface that could ever happen, right? Which is basically what killed SOA in my mind. If microservices, what we're talking a lot more about is, kind of do the more agile style, right? Build the bit, right, that you need, make it start working, start using it or whatever, then build the next bit. And at least my approach to containers, and I think a lot of people at Red Hat share this opinion, is you should do the same thing when you're kind of trying to containerize applications, right? There's no reason that you necessarily have to start with perfect microservice architecture. Just take your big application, shove it in a container, okay, and then start operating it like a container. And then once you start to identify the services that you need, start pulling those out, right? Do the agile style. You don't have to kind of come up with the entire set of sliced bread at the beginning. You can kind of just start off the way you want to, with what you have, and then kind of move slowly into an environment that is more scalable and more manageable and that kind of stuff. So, unfortunately, the software we can deliver isn't going to help you with some of those choices, right? So what we do try to do with the Container Development Kit is that it's more than just software, right? It's lots and lots of how-to guides and that kind of stuff to try to guide you around that path. And speaking as a former consultant, right, this is where some consulting sometimes helps, right? Not that I'm biased, but but what we can do is we can kind of help you with, particularly for developers, is kind of getting that environment set up, getting that integration done so that it's easy to kind of launch and build and use containers while you're both kind of experimenting and trying to see how it works, and then while you're trying to do some of that development. Because, one of the things that they kind of tend to gloss over with a lot of these infrastructures is when you have massive horizontal scalability, right, that usually means a massive amount of setup and management and all those things, right? And doing that for every given developer on their laptop, that's kind of tough, right? So that's what kind of the software side of the CDK is trying to do, and that's kind of what I'm going to show you. So definitely check out developers.redhat.com, developer blog. That's kind of good TOC to start you off into the content. So, kind of covered this a little bit, but I like to make sure everybody sees the marketing pitch. This is what the CDK is. I'm not sure I even know what it says. Read it if you like. But this is what I think it is, right? So, and basically what it is a Vagrant VM. So Vagrant is this really nice piece of software that kind of manages virtual machines for you. So it's actually really funny. Until I started working with the Container Development Kit, I'd never really tried Vagrant because I've been using VMs for years, right? There was didn't see its appeal. And then I started working on the Container Development Kit, and I was like, man, this thing is cool. Basically I can take this one text file, a Vagrant file, and modify it such that, as a team lead, right, I can kind of say, okay, this is what the VM should look like. I run through provisioning steps that actually sets it all up and all that jazz. And then I can just share that file to other people, right? I have to share an image too, but I can share that file with the rest of my team, and we actually know that we're all working off the same thing. So it's really cool, and even if you know VMs, I highly recommend checking it out for kind of general use cases as well. But so what we use it for is we kind of we ship a RHEL virtual machine, which then has a Vagrant file that kind of sets up Docker and Kubernetes and OpenShift, so that you kind of have your own little micro instance of it. The nice thing about how this setup is we try to set it up as close to like a recommended production deployment would be as well, except smaller, right? So that some of the issues you're going to run into in production, you hopefully will run into in development, right? That's not to say that you shouldn't do CI and all that jazz, but it definitely is a good start to actually have an infrastructure that looks like the one you're going to have in prod, at least in my mind. Unfortunately, I wasn't keeping track of time. So, okay. So what else? I mentioned the how-tos and examples. And there's this Eclipse integration. There's also a lot of command line integration as well. And I may show you a little bit of that to explain it. Okay, so this is kind of a set of bullets of kind of like the high level of kind of what Docker containers are. And one of the things I like to point out about containers, right, is that Docker is actually one implementation of a lot of different container technologies. It's interesting, actually, OpenShift V2, so the prior version, essentially used a container technology, but it was kind of more hand-built. And so we're starting to see a lot more because kind of the popularity of Docker has made kind of, hey, we have these container things. We've been doing these for a while. So you're starting to see a lot of, I would say, polishing kind of around a lot of the container techs that already existed, and then new ones coming out based on some of the older stuff that kind of have different goals and things like that. So, Flatpak is kind of one coming from the GNOME group, which is tries to provide basically UI-based containers. LXC is one of the ones that's been around forever. Rocket is one that was originally from CoreOS, but it's had a lot of other contributors. They all have different trade-offs, right? Docker containers are super, super developer-friendly. And Flatpak, for example, right, is very UI friendly. So Docker containers are much better for server applications and not so good for UI applications. Although there's a lot of projects out there doing like full desktops in Docker containers, which I think is really cool. Then the thing is about Docker, though, is that it's kind of meant as like, I mean, I don't know if it's meant this way, but the idea is like it works really, really well on one machine, right? And you can kind of connect your various containers together and have them talk to each other. But it doesn't kind of start to bring in other machines. Some of that's changing with some of the technology they're shipping lately. But the solution to that Red Hat kind of chose is one from Google called Kubernetes. And what that is it tries to manage kind of an environment of containers. So, basically clustering, right? So how do I get a bunch of machines participating in running Docker containers and making sure they can like talk to each other and making sure that they can share data between them, or sorry, not share, but like communicate with each other and find each other and things like that, even as the Docker containers are moving from like machine to machine. Then we have another project that we've been working on for a while, but we revamped OpenShift with V3 to actually use Docker containers and Kubernetes directly rather than kind of the homegrown version of the same kind of thing that we had in V2, so that it'd be more kind of cross-compatible with the rest of the ecosystem. So what OpenShift does is it kind of takes basically exactly like Kubernetes and then kind of adds management on top of it. It adds routing kind of on top of it so that kind of the rest of the feature set that you want to have in a kind of production deployment, as well as the feature set as kind of a developer, right? So like OpenStack is really cool, but it isn't very useful except for that UI that lets you click the button and say, give me a VM, right? So OpenShift kind of brings that part to the table. So like I said, both kind of for the developer side of it, developer facing, and kind of the sysadmin side. So I talked about this a little bit already, but just to kind of give you a graphic around Kubernetes, this is a freely available graphic on some blog, which I meant to put the link in here, and I think I forgot. But basically, what you have with Kubernetes, I think Docker is relatively easy to understand, right? Basically, you have, for lack of a better term, a tarball of all the binaries in it that you need to run that service, right? And then you can link them with other Docker containers so they can communicate. And so then you kind of add Kubernetes, excuse me. And what Kubernetes does, it first has a concept of a pod. Okay, so a pod is when because sometimes what you need is several containers to offer kind of one service, Okay, so the idea of a pod is like a set of containers that need to operate kind of together, right? And so generally speaking, they need to be on the same machine and be able to communicate with each other directly. So then you might have a few pods, right? So you kind of have a pod per service, but you also have this concept of a service in Kubernetes, which allows for a layer of indirection between kind of the interface to the service and the thing that's providing the service in the pods so that you can scale, right? Then you can kind of link the services together, and that's kind of how you get your microservices, and then you put some kind of application or whatever that's going to actually communicate to all those microservices. Some of the other graphics in here, so you have like replication controllers that kind of says, okay, how many of each of these things do I need running at any given time? And then OpenShift kind of adds a layer on top of that to do the auto-scaling stuff. And then you also have, the concept of a node, which nodes are essentially VMs, kind of running your Docker container, so basically places you can deploy to in your cluster. And you have schedulers, and there's an API server, which is basically how you interact with Kubernetes. Is it making sense to everybody so far? All right, cool. Feel free to ask questions. I don't usually lose my train of thought. Now it'll happen. So then kind of moving on to OpenShift, right? So you kind of see Kubernetes kind of in the center there, right? And so what OpenShift adds is kind of a lot of that kind of functionality around it. This is a hard graphic to show because it changes a lot. Because we work so closely with the Kubernetes project, we get a lot of, they see stuff we do like in OpenShift or whatever, and they're like, oh, maybe we should put that in Kubernetes, right? Or, or then, there's a back and forth about what things kind of belong in OpenShift and what things belong in Kubernetes. So this can be a little bit of a hard picture to pin down. We also work a lot with the Docker team as well, putting patches in and stuff like that. So they, so the whole ecosystem, it's all open source, right? It is all very collaborative. So you get a lot of people kind of working on it. And there's, with any good architecture, right, there's a lot of debate about, does this piece of functionality belong in this part or that part or whatever? And sometimes they change their mind, right? So the last thing I want to show you is, so this is Max Anderson's graphic. As you can see, he kind of used the same graphic I did before, but he shows the IDE and the human, and I thought it was funny, so I included the picture. But basically, this is kind of what the CDK is, right? So on your laptop, you kind of have a big box that is your VM, which is running all that stuff. And then you have your IDE or your command line, and then you have you sitting at the laptop. All right, so let's see how the demo gods fare. Oh boy, that's really big. All right, so what I was trying to do was kind of preload all this stuff so that it would go quickly and I could just kind of show it to you. And it was working really well all morning, and then I kind of deleted it all so that I could make a new one so it'd be nice and clean, and that one didn't work. So we'll cross our fingers here. Okay, so let me show you first. Actually, I can do it from here. Excuse me. So where is my window? Okay, with Eclipse now, there are a few different tools. There's a Vagrant, what do they call it? Vagrant tooling. There's Docker tooling, there's OpenShift tooling, and kind of JBoss tools as well. And if you're familiar with Eclipse, right, which I assume most of you are, you kind of add these plugins and kind of give you functionality in Eclipse. Excuse me. So if you go to the JBoss tools and do the install there, you actually get you can kind of choose all the JBoss tools, but within there you can actually kind of choose these individual bits. So that's kind of, I found it to be the easiest way to kind of get it kind of all there, but you can obviously add each plugin individually or whatever. So the first thing I'm going to show you is, if I can use the mouse. So there's kind of two views here, and this is the one I was looking for, which apparently is here somewhere. Oh, there it is. So Vagrant has this concept of a box, and it has a concept of a VM. So a box is kind of the object, and the VM is the instance. So I have a box on here called CDK, and then whenever I create an instance of that Vagrant box, then I end up with a Vagrant VM. So you can see here I have Vagrant. I have the CDK running. And remember, I was telling you about the Vagrant files. You can do different Vagrant files to kind of do different things. So the CDK actually ships as one VM, so you have one Vagrant box, and then you can choose whether you want the kind of OpenShift experience, and so you choose that Vagrant file and launch it, and you get full OpenShift. But if you're not using OpenShift in an environment, or you want to kind of get closer to the details, there's another Vagrant file that will launch just Kubernetes and Docker. So you kind of just choose on launch which one you want. So as you can see, I actually have, or I did have, maybe I deleted it. So you can have just a CDK. You know, I could have 16 of these, right? They don't all have to be running at once. As you can see, most of them are shut off. And what they do is essentially overlay images, so they don't take up a lot of space. So you know, you kind of just, you normally do it by project. So I have, and actually, I can show you. Theoretically. Oh, boy. So this is basically the file that we ship. I made a little bit of change down here to say, hey, call this one CDK underscore OSE, just so that I could keep track of which one it is. But essentially, it's an unmodified file. Let me see if I can get back to my view. All right, cool. So now that's running, and I can now do arc. My mousing skills today are terrible. So I can actually, yes, I can actually SSH into the machine itself. You can do this from the command line, Vagrant SSH, if you're in the correct directory. I can log in there, and you know, and I can kind of interact with it as if it was, you know, kind of a normal running machine. So I can do stuff like, you know, Docker PS, right? Which kind of just tells you all the Docker containers that are running. But I can also do cool other things. Let's see. Like I said, sorry that a bunch of stuff broke on me here. I gotta find the right window. So the Docker actually has its own perspective, but I was trying to make it so you could kind of see this stuff. There we go. All right, so let me see if I can get that to go up here. So what you do is you just kind of add the TCP connection and that kind of stuff to the machine. There's actually an easier way to do it, which I think I forgot to show. But so here is, wait. I think, yeah, sorry about this. It was really kind of frustrating. That like everything blew up on me. Let's see if this is going to work for me. Yeah, good, good. Yeah, I know. That's why you were angry earlier. All right, so suffice to say, I can get to the Docker Explorer, and then I can look at, okay, so Docker talks about two different things. Again, kind of an object version and an instance version. So there's a thing called a Docker image, which is the object, okay? So, and then you can have instances of it called containers. So it's actually really a misnomer for us to talk about Docker containers or containers in general all the time, because that's really the object, not the instance. So, all right, so if you notice here, and let me see if I can make this bigger. There's a ton of stuff running here. And the reason is because OpenShift itself is running as Docker containers inside Kubernetes. And so it's doing all those kinds of HA and that kind of stuff. So you could kind of go in here and examine the individual ones. And they're kind of, there's actually, sorry, this is also showing some of the ones that are exited. This is up 3 hours or whatever, so, typical, UI construct, you can kind of say, okay, show me the ones that are running or not running or whatever. But so those are the Docker containers that are running, and then, and these are the images available, so I could just launch new ones if I wanted to. However, that's a lot of work. So I was more going to show you kind of setting up an OpenShift project. And what's nice about when you create the OpenShift project, it actually gives you, or like if you want to use one of the examples or whatever, you actually have the Kubernetes configuration files and the Docker configuration files, so that you can kind of go and experiment with it directly if you want to, or kind of deploy it in an environment where OpenShift isn't, et cetera. And this is the part that blew up on me, so hopefully it will work nicely for me. So let's see. So first I go do an OpenShift application, intuitively enough. And basically you have different creds for different users in OpenShift. All right, so I find this to be the most confusing part at the beginning. Is the first thing it wants to do is it will try to use the default project even when you do new, so I find that a little confusing. So make sure you don't screw that up like I did like 87 times. So we're going to do my cool Summit example. And cool. Okay, and so the next thing is I'm going to leave the Eclipse project blank, because I'm going to use an example and it's going to kind of create a project and all that jazz. I'm also going to use a node example, mostly because it's fast, to kind of create and that kind of stuff. So I choose the node quick start, and I just kind of walk through here. Okay, so one of the things that I didn't really mention is like the way kind of information is passed to your service, or like to your app inside a container, is generally speaking through environment variables. So basically you inject a whole mess of environment variables into the container on launch. And so in there will be things like database passwords and database URLs and all those kinds of things that you need kind of inside your application. And change, right, between the different environments. And the way they do that is they inject it all with environment variables. So what you're seeing here is the kind of environment variables that this particular Docker file or Docker container expects. And I'll show you guys an actual Docker file too, so it'll make a little more sense. All right. Hopefully this is going to work. We'll see. Yeah. All right, whatever. I feel like I'm going to have to like rebuild my entire machine after I do this talk, because I have like stuff all over the place. All right, so in theory, that will be, so what that's doing right now is actually, you can see right here, let me refresh it, but, so, okay, so what's going on is, so that's the server, OpenShift dev there, and then my project is my Summit example, right? And then this particular example, all it does really is deploy a Node.js server as a container, right? And so but it's doing it inside like Kubernetes, right? So it's, let's see if I can show you. Maybe? I don't know what that IP is. So you can do, there's a nice little link. Oh, here we go. So I say OpenShift devel, default username and password. So you can actually see kind of in the console a little bit more like kind of information about, kind of deploying and doing all the cool things that it does. But so you see right now it's still building it. Yeah?
You built your own private OpenShift environment and run everything through.
Yes. Sort of. Okay, so the question is like, kind of, sort of, right? Is everything done locally and everything done through Eclipse. So, okay, so what I actually did was I went to developers.redhat.com. I went to find the link that said download the CDK, right? And I happen to be on Linux, so it's actually a little harder. But on Windows, there's a nice little installer. You click the install button and then wait for a while, right? And what that actually does is it goes and downloads a Vagrant VM. So it's a it's a VM image. So I think we support like Hyper-V, VirtualBox, and KVM. So it downloads the right one for the kind of the platform you choose, and it's a decent-sized VM image, right? But so it downloads that, it shoves it off into Vagrant's magical storage area, and it calls it a Vagrant box. Okay. Then what I did was in the little Vagrant boxes thing, I say, okay, right-click, launch, right? So then it launches it, and now I have the VM running. And because I chose the Vagrant file that said launch OpenShift, it reached into the VM and launched the OpenShift. Then I went and connected Eclipse to the OpenShift itself running in the VM. Then I said, create new example project. That make sense? Cool. All right. Hopefully I explained that right. But yeah. All right, that seems unhappy. So I definitely blame demo gods, poor internet, et cetera, for any failures you see. Like I said, it was working great all morning. All right, so this is cooking, right? So basically, what it has to go through is the first step of a Docker container lifecycle, right, is Docker build, right? So it builds the image, and basically that goes through. Let's see if I can find the Docker file, which should be in here somewhere. Wait. Yeah, where's the Docker file? Let me just show you a random Docker file because I'm not finding the right one. So this is a basic Docker file. Okay, this one actually happens to launch Drupal. And a random plug here, this is actually uses software collections. So this is, what, a 23-line file. But if you do this by hand, which I also did, it's like 4 pages. It's huge. So heavy plug for software collections. But as you can see, it's basically a bash script, right? Kind of with a little bit of extra keyword magic. And so when you do the build, what it does is it actually goes through and creates each of these as layers, they're called. Each line is a layer. And so that's why if you notice like line 5, you see how I'm doing a bunch of and signs? That's so that I end up with one layer. And the reason I want to end up with one layer is because if I rebuild this, it'll reuse any layers that haven't changed. So if you want to do fast Docker file building, particularly when you're doing development, what you do is you kind of do the stuff that you know is right at the beginning, right? And then kind of you experiment closer to the bottom so you can get advantage of the caching. So what the OpenShift server was doing was it took my Docker file, which I can't find, but took my Docker file and did Docker build on it and kind of ran through all these steps and created all those images. And it's going pretty quickly because I did it earlier. Right? And so, like I said, it's all cached, right? Then what it did was it created a pod out of it. So it should be in here. And let's see. So somewhere in here is a pod. Where is this guy? Yeah, this is definitely Demo God's day today. Okay, so basically it creates a pod, which is defined in a JSON file. This is a Kubernetes JSON file. This is how Kubernetes works, is it's all JSON files. So it defined a pod, and that pod, it says, I must have at least one of these Docker containers running in the pod at any given time. Then it slapped a service on the front of that, okay, so that you could do that indirection layer. And then it, like I said, and then there's replication controllers. And then it does, and then what OpenShift, one of the things it adds is the routing on top of that, right? So then OpenShift, what you saw it doing was, let's see, maybe it just needs to refresh here. Yeah, so, all right, this is what it was doing before, so it's making me a little nervous. But so it builds the image, then it basically puts it in a pod, and then it kind of shoves it into Kubernetes, and then Kubernetes says, oh, okay, I need to have at least one of these containers running, so it goes and spins up one of the containers, and then if I go in and kill the container, it'll actually come right back, right? Another one will get launched, and it'll continue on its merry way. And then the routing goes in, and we get this nice thing here, but see, this is what I'm afraid of, is it's not actually deploying, because I don't know why. It normally works great. So I haven't quite figured out what the deal is. But so that's kind of running the pod and the containers and all that jazz. And then you can kind of make modifications to kind of your deployment structure and all that stuff. But at least for the most part, particularly in development, right? This is all the stuff you don't care about. Right? Like, it's like, okay, yeah, make it go up and do stuff. And then when I click in the web page, it comes up, right? That's really the part you mostly care about. So that's what I like about using it with OpenShift, is that's kind of really hidden off to the side. And then doing it with Eclipse, I can really just like right-click and launch stuff. And generally speaking, it's worked great. I think it's something to do with network and messiness and me turning off my laptop kind of stuff. That's most of the stuff I wanted to show you. It would have been nicer if I could make it work, but let me see. Maybe sample project will work. Let me see if I can get that at least. So up here, you kind of have like this guy. All right. There you go. So you can see it's running there, and so if you notice, this one is actually using a Mongo database, is one pod. So that's what you're seeing here, right, the pictures. And you see that it has another pod, which is your Node.js server, and then it's injecting information through that service layer, right, not directly, so that they can communicate with each other. And then you can kind of just, up it and stuff and magic. Right, which is cool from an ops perspective. As a developer, like whatever, I just need to make sure. Like the only reason I push those buttons is to make sure that it still works if there's like 3 of them, right? But then you kind of continue on your merry way, and and then you get your super awesome example project, which I think is a dead thing. One just side note here: there's this cool web service called Zip.io. So all this is doing is you pass it the IP address of the internal machine that you want to hit, and it basically passes it back as DNS, so that you can solve that never-ending routing problem of like how do you route to your own machine easily without having to do routing all the time. So I really like it. I think it was set up by the Basecamp guys maybe, but it's cool. I think that was pretty much all I wanted to cover. Did anybody have any questions or things I didn't cover well? Yeah. Well, it's actually, it's through. So you kind of can do it in different places. So I'm not sure, because it's the example app, how it's doing it. But so if you look at the Docker file, we'll have. Bad example. But so normally you can, in the Docker file, you can expose ports, but you could also, you do it in the pod as well. So yeah, see the 8080 kind of there? But I have a bit of a mismatch between my demo and the right code. So I think it was, I'm not sure what port it was actually listening on. Oh, okay, so maybe there's an HTTPS port in here too. I think it's the same, so it should be the same. But yeah, that's basically how you do it. And one of the things that to remember about Docker is that if you don't specify a port, it'll actually make one up. So you have to remember to go and when you launch it, if you're using Docker directly, you have to go and make sure you find out what port it actually launched on. So yeah, go ahead.
What if you're sitting on a desktop that's like really locked down, or maybe it is a VM and you don't have VM and on VM extensions enabled?
Right.
Can you cause all this to happen at a remove so that like your containers and everything are created elsewhere and you can connect to them, but they're not hosted on your machine.
Right. So oh, actually, everybody heard the question, so I don't have to repeat it. But that doesn't give me time to think about the answer. If you have, like, it's kind of that typical problem. So if you have a shared infrastructure that is providing OpenShift, there you go, right? And you can remotely access that and all that stuff. Part of the reason we actually did this in a VM, like it is, rather than kind of giving you a monster shell script to run or something, is to try to help with that lockdown scenario. Because, theoretically, right, we thought you could get approved from management to put this one VM on your machine without needing root access. Because you don't need root, you just drop the VM on there, and Vagrant runs as a user space kind of thing, so you can just run it. So that said, yes, you can set it all up, but there's a reason that we're providing a VM to make it easier. There is a nice Ansible script now that, and it's on GitHub under OpenShift. I think it's called something obvious like OpenShift Ansible or something, which will actually go and install everything. But it's, takes a while and is a little risky. So does that help?
I think so.
Okay. But yeah, the big reason we did it as a VM and pre-built was to avoid that pain, But you could also stick this VM on a shared server too, and then everybody could use that same one, because OpenShift is multi-tenant, right, or multi-user. So it's, it's good like that. Any other questions? Yeah. So, okay, so the question is, can you bring your own VM? Right, so yes, you can, but it's not quite, it's not cake to set up. Basically, the problem, so Vagrant really doesn't want you on the host machine to kind of know what's going on in the VM. For good or bad reasons. Basically, the reason Vagrant was originally invented was to kind of, or at least in my opinion, right, certainly the major use case early on was you're a web developer on a Mac, and what you need is a web server that you can run your website on and not have to worry about like multiple port 80s, or you want to work on more than one project at a time, et cetera. So I don't know if you guys any remember like XAMPP or any of those things, which kind of tried to solve this problem. Vagrant did a much better job. So what they did was they said, here's your project directory. You make this Vagrant file, and then what it does is it actually mounts your project directory in var www inside the VM. So anytime you edit the file locally, it just shows up. And so you don't really know anything about the fact that it's a VM. So we actually wrote a bunch of plugins for this. So there's Vagrant Registration, which I actually wrote the initial version of, and I'm super thrilled about, is what it does is actually subscribes the RHEL machine for you automatically. So you kind of type in your username and password once off to the side, like there's a bunch of different ways you can do it. And so then every time you launch a RHEL machine, it will just subscribe it, and then every time you halt it, it unsubscribes it, which I thought made my life a lot easier. But another one we wrote, which is basically kind of to your point, it's called Vagrant Service Manager. And so what it does, it's kind of a grab bag a little bit, but it reaches into the VM and grabs various kinds of information. So it does like systemd, like enable and restart and stuff on the OpenShift stuff. It grabs the client cert for Docker, so that the Docker client on your host machine can talk to the one in the VM, because it uses SSL to do it. So it does a bunch of stuff like that. So yes, but you might have to. What I'm wrapping up in that Eclipse plugin for OpenShift is kind of the nitty-gritty of like getting the TLS file and making sure you pass that to parameter to the right place. It's actually funny, when I was first looking at this talk, I used an earlier version of this stuff, and I actually did set it all up that way, but it's more manual. So it will take you half an hour rather than 5 minutes. Which tools? Sorry. Oh, sorry. So the question was, can you install them in the VM? No, they're plugins for Vagrant. So they run on the host, and they'll run against any VM. as long as security's right and that kind of thing. But yeah, go ahead. For Vagrant registration? I thought it did support proxies now. I thought so. I could be wrong. Talk to me afterwards, and maybe I'm misunderstanding the question. But I thought the question was basically, does the Vagrant plugin support proxies? And I thought it did. But I could be wrong. I wrote the initial very bad version of it, and then I shopped it in front of a bunch of people who actually know Ruby, and then they fixed it all and got really annoyed with me, so that made them fix it, which is my normal style of development. Any other questions? All right, cool. Well, thanks for coming.